Hey there. So sounds like you are ready to do some practice scenarios. So these are on that half sheet that you have, and I would encourage you to take that pink sheet that has the boxes like this, so that you can follow along with me as we go through a couple of problems. The more practice you have, and the more active you are in these problems, the easier that this process is going to be. Okay, so this is going to be scenario one, and this is the yo-yo on the floor. So this is exactly like what you guys saw in class, where we spin it around, but again, we're going to add some numbers here. So it says a yo-yo with a mass of 0.41 kilograms is spun in a circle on the ground as demonstrated in class. The string of the yo-yo has a tension of 0.27 newtons as it rotates in a circle with a radius of 0.6 meters. The question asks you to determine the force of the floor on the yo-yo and the tangential velocity of the yo-yo. Okay, so it's kind of a lot of stuff. Let's go ahead and take a look. You have already done the free body diagram for this, but it was on a different piece of paper, and the more we practice, the better we're at. We are at this, so let's do it. So this is the yo-yo itself, okay? And I'm gonna go ahead and draw my string over here like this, just so that we can keep consistent. And then we're gonna draw our forces. So as we talked about before, you've got the force of the earth on the yo-yo, that's Fg. We've got the force of the floor on the yo-yo, that's a normal force. And then finally, we've got the force of tension. And friends, remember that tension is always just going to go along the string. So this is the force of the string on the yo-yo, Ft. Okay? And those are the only three forces acting. Again, we've kind of done this part before, but review is always a good thing. Now, before I get too far in, I'm going to go ahead and write down my givens as well. It says that the yo-yo has a mass of 0.41 kilograms. 0.41 kilograms. I don't know if we're going to have exactly enough room in our little box, but we'll make it work. Says that the string of the yo-yo has a tension of 0.27 newtons. So I'm going to write F sub t is equal to 0.27 newtons. As it rotates around the circle, and the circle has a radius of 0.6 meters. So R is equal to 0.6 meters. And then the question is asking for us to determine the force of the floor on the yo-yo, okay? And the floor on the yo-yo is this one here. So really they're looking for Fn, the normal force, and the tangential velocity, that's V sub t, okay? So those are our two things. Now we just need to we need to write down some F-net equations so we can figure out what to do next. So the first one that we have up there is the F-net in the x direction. We can take a look. There's only one force acting in the x direction. That's F sub t, okay? And if there's only one force acting, then you can ask yourself the question, hey, is it accelerating? The answer is going to be yes. And we know that it's a centripetal acceleration because we know that it's going around in a circle. We'll get back to that in a minute. Let's go back down here and write down our F-net in the y. So there are two, set on yo-yo, sorry. Let me put that back. Fn. We've got the normal force pushing up, and we've got the gravitational force pulling down. And those two are going to cancel each other out because the yo-yo is not accelerating in the upward or downward direction. So while that does equal ma, that a is 0. So the net force in the y direction is 0. Okay. So this part right here, the F-net in the y direction, is going to help us to solve this first unknown. And this is something that we've done a bunch of times already. So we'll go ahead and do this, just kind of get this part out of the way. So Fn has got to equal then Fg, right? Because Fg is going in the other direction. And we remember from way back that Fg is equal to mg. And we know the mass. We know, and I guess I didn't write this down as a given just because we kind of got it in the back of our brain, that g is equal to 9.8 meters per second squared. It's been a while since we've done this. Just a reminder that that 9.8 is negative and that it's going down, but I've already used that negative sign. I use that negative sign right here, okay? So that negative sign doesn't need to be rewritten. So now we can just say that the normal force is going to be equal to, so that's 0.41 kilograms times 9.8 meters per second squared. And that gives me a value for the normal force of 4.02 newtons. Okay, so we're halfway done there. Now, the next part of this asks us to figure out the tangential velocity, right? Now, I don't see tangential velocity in here anywhere, but I can recall and remember from the last video that we just watched that the acceleration, the centripetal acceleration, a sub c, is equal to v squared over r, and that v is the velocity as it's going around in a circle, and indeed that is our tangential velocity. That's what this thing is. Okay, so if we take a look at what we know and what we are looking for, we know the tension, we know the mass, and we know the radius. So we're really almost there. I'm going to put all these things together here so that we can try and solve for v. So if we have ft is equal to m times v squared over r, well, I can solve that for v pretty easily, can't I? I'm going to multiply by r on both sides. So it's ft times r is equal to m times v squared. And then I'm going to divide by m on both sides to get rid of that. And then I've got v squared. I have to think to myself, okay, how do I undo a squared? Well, you square root it, don't you? So we're going to take the square root of ft times r over m. It looks a little ugly, you guys, but I know that you can do it. So let's go ahead and plug our numbers in and see what we get. So we've got the square root of, so our ft was 0.27 newtons. Our radius was 0.6 meters. And our mass is 0.41 kilograms. You go ahead and plug that in. Again, we've said this a bunch of times. Don't rely on the video to tell you how to do this. This is the stuff that you need to make sure you know how to do. So I'm plugging it in. You should do the same thing. Okay, I've got 0.27 times 0.6 on the top. I'm going to divide by 0.41, take the square root of that answer, and I get about 0.63 meters per second. Hopefully that's what you found as well. As always, if you have questions, feel free to ask.